In today's video, I'll be teaching you about isomers or isomerism. What is isomerism? It is a phenomena. Isomers means they are the molecules. Isomers should always be in two in number. You have to compare two compounds. It is a comparison between two compounds. Isomers cannot be one. Isomers itself means it is a comparison of two compounds. So isomerism means it is a phenomenon where they have the same molecular formula but different properties. Okay, they have the same molecular formula but different properties. Under isomers, there are two types. Isomerism also there are two types. Okay, first one we call it as structural isomerism. We call it as structural isomerism. Second, we call it as stereoisomerism. Stereoisomerism. Structural isomerism means they have the same molecular formula. Molecular formula is same but different structural formula. They have different structural formula. In stereoisomerism, molecular formula also same, structural formula also same, but arrangement of atoms in 3D space. Spatial arrangement is different. Spatial arrangement is different. Okay, clear? Now understood? What is structural isomerism? They have the same molecular formula but different structural formula. Stereoisomerism means molecular formula also same, structural formula also same, but arrangement of the atoms in the 3D space is different. Now, under structural isomerism, there are mainly four types. First one, in your class 11 NCRT, there are four types. First one is chain isomerism. Chain isomerism means, take pentane example, 1, 2, 3, 4, 5. What is the hydrogen? 3, H2, 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 H3. This is N-pentane. What is its molecular formula? C5H12. 6, 7, 8, 9, 10, 11, 12. C5H12. Molecular formula is this. Take one more example. I will remove this one carbon and I'll put here CH3, H2, H2, H3, H3. Okay. This we call it as isopentane. Isopentane. You should be familiar with this structure. You have to remove one carbon from the pentane and you have to put in the second carbon atom. In the IUPAC name, we call it as 2-methyl. 1, 2, 3, 4. We call it as 2-methyl butane. In IUPAC name, we call it as 2-methyl butane. But in common name, we call it as isopentane. Isopentane. Okay. See this formula also, it is C5H12. This molecular formula 3, 6, 7, 8, 9, 10, 11. Wait. Here H, only H. 3, 6, 9, 10, 11, 12. C5H12. Molecular formula is same, but both the structures are different. And see the chain length. Here it is 5 carbon chain. Here it is 4 carbon chain. Take one more example. This example, hydrogens you write down later. Here it is 3 carbon chain. So the molecular formula is same, but the chain length is different. Here it is 5 carbon chain. Here it is 4 carbon chain. Here it is 3 carbon chain. Understood? No, this is chain isomerism. They will ask, they'll give this example and I tell to identify what type of isomerism is. You have to say chain isomerism. Second example, take position isomerism. Second example is position isomerism. Here you will see that the position of the functional group or a substituent will be changing its position. Take for example propanol. Okay, na propanol. Here the position is 1, 2, 3. Here OH group is in the carbon 1 position. Propanol. Okay. Change the position of OH. Here it is position of the alcohol group is second. 1, 2, 3. This is 2 propan to all. Propan to all. All means alcohol. Here the carbon, here the hydroxyl group, here the alcohol group is in the first carbon atom, attached to first carbon atom. Here is it is attached to a second carbon atom. Clear, no? This type of isomerism, we call it as position isomerism. See here, one more example I'll take. This is ketone. This is ketone. Okay, 1, 2, 3, 4, 5. This is pentanone. Pentan 2-one. Pentan 2-one. Just I'll change the position of double bond O. Now, okay, wait. I'll make it like this. Now it is pentan 3-one. 1, 2, 3, 4, 5. You should not write here because here also it is pentan 2 only. If you write here O, double bond O, it is pentan 2 only. I'll start numbering like this. Now you change. See here, double bond O position is 2 here. Double bond position is 3 here. Pentan 2-one, pentan 3-one. So these type of isomerism, we call it as position isomerism. Position isomerism, where there is a change in the position of the functional group.